Chapter 11, Lesson 1, question number 18. Taking a look at this problem, we are already given that each side is 5. The arc lengths that make up the rest of the perimeter are a third of the full circumference of the circle, because the measure of each arc that we are trying to find is 120 degrees, which is a third of 360. The circles are congruent because looking at the diagram, each radius is 2.5, which is half of the side length. To find the circumference, we are going to use the formula 2 pi r. Using a calculator and plugging in the radius, we get 2 pi 2.5, which is about 15.707, which is the circumference of one of the circles. Since there are 3 circles and we need to find a third of each one, finding the circumference of just one circle works also. So now the equation would be 15, which is adding all of the sides together, plus 15.70796, which is about 30.70796, which is rounded to about 30.71.
Chapter 11, Lesson 2, question number 24. This problem shows 4 congruent circles inside a square, and the objective is to find the area of the shaded region. To find the area, first find the total area of the entire square, including the circles. This is 20 times 20, and it would end up to be 400 inches. Now we know that each radius is 1/4 of 20, since the radii is congruent, and the diameter is the radius times 2. This means the radius is 5, and the diameter of each would be 10. To find the area of the circles, use the formula pi r squared, and replace r with the radius, which is 5, and then square it. This would end up to be 25, and therefore each circle's area would be 25 pi. All 4 of them would be 100 pi, which simplifies to 314.159. And after subtracting this from 400, which is the total area, the result would be 85.84 inches squared.
Chapter 11, Lesson 3, question number 49. For this problem, we need to find the area of the whole shaded area. In order to find the first shaded area at the top of the shape, we would need to find the area of the hexagon and then subtract the area of the pentagon from it. First, we need to find the length of the apothem, which we can do using the Pythagorean theorem. 4 squared plus a squared equals 8 squared, which would simplify to be 16 plus a squared equals 64, leaving a to be about 6.93. Now multiplying half of the apothem, 3.4641, by the length of the side, 8, by the number of the side, 6, giving us the area of the hexagon, which is about 166.28. The first step to finding the area of the pentagon is finding the apothem by using tangent. Each angle is 72, so to find the apothem we would do 4 tan times 36, which is 5.5055276. Then you would multiply half of the apothem, 2.7527, by the length of the side, 8, and the number of sides, 5, giving us the area of about 110.11. Now, 166.28 minus 110.11 equals 56.17. Now we need to find the area of the second shaded region, which we can do by subtracting the area of the triangle from the area of the square. The area of the square is 8 squared, which is 64, and by multiplying half of the base by the other side, 4.6.928, we will get 27.7128. Now, 64 minus 27.7128 equals 36.2872. The last step would be to add both areas of the 2 shaded regions, 56.17 plus 36.2872, which gives us the total area of about 92.
Chapter 11, Lesson 4, question number 28. This problem has multiple steps and includes finding the perimeter and area of cross-sections. First, we need to take a look at the diagram and identify the shape of the cross-section. In this picture, the shaded area in purple represents the cross-section and is shaped as a rectangle. Now, to find the perimeter, we need to find the side length of the cross-section. The cross-section divides the cube into 2 congruent triangles, so we are able to use the Pythagorean theorem to find the side length. since a squared plus b squared equals c squared. Both a and b are 6, so it would be 6 squared plus 6 squared equals c squared. 6 squared is 36, so 36 plus 36 is 72, and 72 would be the length of the hypotenuse. Now we know two side lengths of the cross section. The final two can be seen in the diagram since the shorter sides are an entire edge of the cube, which is told to be 6. To find the perimeter, add up all the sides, which is 72 plus 72 plus 6 plus 6, and the answer would end up being 156. To find the area, however, use the formula length times width and use the information we found above. We know the side lengths are 72 for the longer sides and 6 for the shorter, so take one of each and multiply them together to end up with the answer of 432.